that we have currently today. And so that's sort of, like I said, the citywide network going from, sort of, Northbridge to Encino or to Reseda or to other places, more comfortably. That's it. Our neighborhood network is about the same mileage, 672 miles, of what we're calling bicycle-friendly streets and also bicycle routes. And bicycle-friendly streets basically is kind of like a bike boulevard, for those who are familiar with that term, from Berkeley. In essence, a street that has treatments on it that kind of calm traffic and are kind of more geared towards cyclists and not necessarily geared towards cars speeding through or using those streets as shortcuts. Generally, they're characterized by low-volume traffic streets and slower speeds. And our goal is to have sort of a 1 mile interval of those streets versus the 2 mile grid for the citywide network. And I'd say before, kind of connect local destinations, schools and libraries and local community facilities. And also understand that some of those streets are more comfortable to ride for the average rider. Some folks aren't necessarily comfortable riding on Reseda and want to ride some of the paralleling streets that have traffic lights to get across the busy intersections, but may not have the same amount of volume of traffic. This sort of maybe a little hard to see for you guys, but kind of just an example of the proposed network within the valley. You guys are, where can I go? Here. A little tough to see. But you can tell there's some streets that flow in and out of campus. I understand that there's a plan that the school is embarking on to make the campus a much more bicycle friendly and accessible. And I think our plan, their plan will definitely complement our plan as well. And I'll just kind of go through the slides. These are different parts of the city. So it shows you it's not just a thing for the valley or a thing for South LA or West LA. This is for the entire city of Los Angeles. And so it's the southern and south areas. And as you guys may realize, all different parts of the city were built at different times and have different challenges. Some are street widths. Some streets are very wide, especially in the valley, kind of newer streets that were built with different purposes. When you get over the hill in central Los Angeles and South LA, you have very small streets, but still very congested and very heavy. And so our challenges are how to implement facilities on those varying types of streets. One of the other challenges are kind of the dominant car culture, kind of a car-oriented, centric environment, not just socially, but sometimes even some of the rules and regulations that we have to deal with today are more geared towards cars than they are towards other modes. Funding and staffing, there is a lot more money out there today to implement facilities. However, as kind of widely out there, there's budget challenges that all municipalities are facing, especially here in the city of Los Angeles. And so we may have money to actually build facilities, but don't have staff to actually go out and put them on the ground. And also ongoing maintenance. It's great to build something, it looks shiny, looks brand new, but year after year kind of wears down, and it's hard to really maintain certain facilities. The implementation is twofold. It's by departments, and planning, the Department of Transportation, Department of Public Works. Also physical improvements. We have a 5-year implementation plan that we're proposing that'll help kind of have a consistent way of building facilities on the ground versus kind of the piecemeal approach that we have today, with the goal of 200 miles every 5 years and maybe even more faster than that, or more miles than that. There's a technical handbook that kind of guides the design of facilities. Things just don't show up and paint just can't be anywhere. There's certain criteria and guidelines that we have to adhere to that come down from the federal and state governments. This is just kind of shows an example of the amount of footage and distance that's needed for certain facilities. In our next steps, just to kind of wrap up, we've had a series of public hearings this past September and October. Actually, one here in the Valley, we had in Van Nuys. And we're gearing towards a City Planning Commission date of November 4th, which is next, I think, a week from tomorrow. And that's our first kind of formal adoption step to make this plan kind of a reality for the city. And then after our City Planning Commission, the mayor and the council for their final blessings and approval. And after that, the plan will become the new plan of the city, replacing the plan that was originally adopted in 1996. So with that, this is my info, and it's a very abbreviated presentation, so if you want a copy of it or have questions, my contact information is up on the screen, so feel free to email or call or write, and I'll be glad to answer any questions then. And this is our project website, which contains all the maps and information of what I just spoke about, and also much more information that I wasn't able to get to today. So with that, thank you guys very much.
Today's session is going to be about the history of alternative transportation and vehicles. Professor Davidson, in the Department of Geography, is going to talk about the electric car, known also as the red car or Big Red, and what that has done to space in the city of Los Angeles. Leslie Kendall is the curator of Peterson Automotive Museum. He has had a lifelong passion for vehicles, different kinds of vehicles, and you'll hear today about such vehicles as the locomobile and the dudgeon. Pat McLaughlin is the Director of Transportation and Management at Moore Lacafano Gulfsman Inc. And she's going to speak today about the challenges of the 710 corridor. She's helped to work on the environmental impact report and the environmental impact statement, and we'll talk about the past in that area and what's going to be happening in the future. First speaker is going to be Leslie Kendall, please.
How many people have been to the Peterson Automotive Museum? How many people have heard of the Peterson Automotive Museum? Peterson Automotive Museum is on the corner of Wilshire and Fairfax. It's the third busiest intersection in Los Angeles. And we took over a disused department store, Orbox department store, that had been Bag Lady Central for several years before Mr. Peterson got the idea for a museum. Does everybody know who Mr. Peterson is? Have you ever heard of a little magazine called Motor Trend or Hot Rod? Well, he founded those magazines, and he was president of Peterson Publishing, and he had a whole lot to do with the car culture that we're experiencing in Los Angeles today. Well, the Peterson Museum is on. It's three floors of exhibits. The first floor is what we call the streetscape, which takes people on a roughly chronological tour of LA in the automobile. It's giant dioramas that kind of walk people through history. And on the second floor, we have giant galleries, some that are 10,000 square feet. And we have different themes. We have Hollywood as one theme. Right now we've got fiberglass cars, because that was really innovated in Los Angeles. We've got Cars of the Stars. We've got Cars and Fashion right now, which shows the intricate relationship between automobiles and fashion, two of the most personally revealing things about people. And indeed, in Los Angeles, we say that you put a car on as much as you get into one, because it really does become another layer of clothing. So.
Question.
Oh, question. Yes.
You get a student discount to get in?
Yes. $5. Bring a friend. Sorry about that. Here we go. History of power from horses to hydrogen. And my presentation is going to be perfect for those with a short attention span, because each slide is only going to be up for a moment, shorter than I thought. I'm going to go forward and back right here. All right. Everybody with me? Thanks for bearing with us. I appreciate it. All right. Horses to hydrogen. In the beginning, anything other than human power was considered alternative, such as the horse. The naturally generated mechanical power came up, and then artificially generated mechanical power. And then somebody got the bright idea of applying artificially generated mechanical power to move a vehicle. And it's real interesting that the very first, one of the very earliest vehicles that applied such power was motivated by thrust, much like the land speed record cars of today. A guy named Leonardo da Vinci had a little spring cart that he conceived. I don't know if it was ever built in his day, but there are a couple of replicas that are out there now. I don't see too many people running around in them, so I'm pretty sure we know where that technology went. The winner is steam. This vehicle you're looking at is the very first car ever built in the world, and we're very lucky it survives. It's a 1769 Cugnot Fardier à vapeur steam horse, and you can see it's just huge. And if you look at the little seat, it kind of gives you an idea of the vastness of the vehicle. Steam was produced in the boiler in the front, and there were two brass wrapped cylinders on either side of one on either side of the wheel that propelled it. It was just like so many other innovations. It was intended for military use. It was to carry armaments and things like that. Well, the world's first car had the world's first accident, and that got people a little bit afraid. They thought, oh, wait a minute, these contraptions, man, we'll never get these things to work. Forget about it. Back to the drawing board. The idea didn't die. It just hibernated. By the early 1800s, steam had reappeared, but early applications were not for private use. And how'd you like to drive around in this? It's an 1803 Trevithick steam carriage. The little red cab, I don't know how you would get up into that with 9 petticoats and all that sort of thing. But they didn't call it the steering wheel, they call it the influencer. And you practically had to have a degree in steam power to operate this thing. This is not a car you get in, turn on, put your iPod in the dash receptacle, and drive off. This is something you really had to plan around, and I don't think it went very far. The idea of personal autonomy held such promise that experimentation continued. People thought, man, this may not be exactly the thing, but we're kind of on the way. And here's the dudgeon that was spoken of earlier. And you can see it's kind of like a railroad car without the rails. But I'd like to point out again that you've got a special person that's just in charge of keeping the head of steam. Then you have the Bolet, a French car, and again, these things are giant, and they're just not made for individual use. But people persisted with steam, and why did they want steam? It was available technology. It was something they already knew about. It was familiar. It was easy to understand. They could get their minds around it. It was straightforward to engineer. It was simple to fuel. You had water, you had kerosene or wood, whatever burned to heat up the water. You have maximum torque at 0 RPM, which means you can really take off from a standstill because you build up. Ever heard the term build up a head of steam? Well, that's where they got it from. You build up the steam, then you let it go, and you have the most pressure at the very beginning of the cycle. So, and it's powerful because of that. There's the Locomobile. Locomobile obviously was a company that, well, maybe not obviously, but it was a company that also produced locomotives. And so the steam's kind of a natural, but you see how small steam cars had to become before they became accepted by people. And this was 1900. Here's a white steamer. This is one of the first cars in the White House motor pool. When the White House got the very first cars, and I think it was 1910, they had 1 electric, 1 steam, and 2 gasoline-powered vehicles. Here's a Stanley steamer, the coffin nose Stanley. I think everybody's heard of that, at least the carpet cleaning company. Then why not steam? Well, there are a couple of reasons. It's time-consuming to start. If you live in Detroit, February, you're going to have to plan well ahead. You're going to have to plan before you go to bed that you're going to take your car in the morning. It's complicated to operate. You have to watch all kinds of gauges. You have to make sure that the pressure is such, and you have to make sure that everything is lubricated properly. And you not only have the water to worry about, you've got the fuel, and you've got the lubrication, and you've got all these kinds of things. It's difficult to maintain. You had to clean out the burner. You had to do all this thing. You had to blow it down afterwards, which means you had to blow all the steam out of it. Hazardous if not maintained properly. More than one of these things blew up. So it's not for the faint of heart. And high fuel consumption. When you say high fuel consumption, it doesn't mean what we think it means. It means these things used a lot of water, and they used a lot of kerosene. They used a lot of whatever it was that was heating the water. In other words, it was inconvenient. It was a pain in the neck. Steam progress stalled despite a change in styling. And remember the cars that we showed before, they looked different. I mean, they looked like steam cars. Then, as now, there was a pretty big public resistance to anything that looked different. So even though steam cars like this 1925 Stanley adopted